Hello, my name is David Roure, and I'm based in the Oxford E-Research Centre in the Department of Engineering Science at the University of Oxford. I'm part of Petras, the National Centre of Excellence in Internet of Things Cybersecurity. This short video is about a project called Integrated Cybersecure Edge Computing, which was funded under the Petras Opportunities Fund. This 3-month scoping study has produced a report entitled Designing an Integrated Secure Information Architecture for Digital Twins and Cyber-Physical Systems. The project was developed by my colleague Paul Watry, and I had a fireside chat with Paul to discuss the study, which we bring you in this short video.
Okay, so the UKRI is currently developing a design and ultimately construction of a fusion reactor device at Culham. And it's a commercial project, and it's designed essentially to put power onto the grid within the next 20 years or so. I might also add that the scale of the project is overwhelming because it involves petabytes of data transmitted almost daily over networks, distributed simulations, and other things which we barely know how to do. So to model a whole nuclear device is a challenge which currently we have to invent the methods to do that. So we have what we would claim is probably the most complex engineering project ever attempted in silico. And we also in this country have something called the National Digital Twin. And that has a slightly different remit, but in a sense, many of the lessons that we're drawing from the atomic energy work, UKRI work, are lessons which also can be applied in the context of the National Digital Twin, which is now being developed to provide federated twinning between different technologies and different domains. And the National Digital Twin has additional challenges. It has a social agenda, but it also looks more carefully or more focusedly at the issue of smart cities and how we organize that. There are commonalities between the two projects, but primarily a big issue comes from the heterogeneity of the different systems, networks, data, etc. So it becomes a problem of managing heterogeneous data, managing an ecosystem which is constantly evolving, and understanding how the components can work together seamlessly in a secure environment. So the issue here is that if you use one system, that's not impossible to do. But if you have a federated network of digital twins using different systems and different technologies, and the technologies will evolve over time, how do you manage these processes? How do you track them? How do you understand security from that perspective? And that's much more complex. When you start to add edge computing into the mix, which we barely understand, then what you really have are a complex array of issues which are at the frontier of research. They're all open research questions, and we need to understand those more completely. So I would suggest that these issues which we are looking at from the perspective of building a nuclear fusion device may be able to inform in some way, shape or form the way that these could be implemented at a national level for the National Digital Twin. To give you a scale also of these issues, we're looking at distributed data across different organizations, across different national boundaries, different jurisprudence environments, across companies, academic research institutes, contractors, et cetera, with an extended supply chain. So that was the basis of the report, looking at these issues at a high level and not really addressing the solutions because these have to evolve, but really setting out at a high level the problem space and making clear that these issues will increasingly have to accommodate fog computing or edge computing environments.
Thanks very much to Paul for the chat. For more information about the study and a copy of the report, do take a look at the Petras website. Thank you for joining us.